Welcome to today's lesson. My name is Yamasaka Kriandens. Well, today I'm going to take you through another very interesting lesson, that is organic chemistry. In particular, today we'll look at organic acids, and we'll go straight to the lesson for today. Okay, as I stated earlier, I said today we're looking at organic chemistry, and in particular, we'll look at organic acids. Well, we'll straight away look at how we can name organic acids. Actually, the E on an alkane is replaced with the OIC, which is oic, and the acid is added in front. So for an alkane, the E at the end of the alkane is replaced with the OIC, which is the oic, and then you add the word acid in front. And so the organic acids have a functional group, which is actually carbon and 2 oxygen and hydrogen. And this is known as the carboxylic group. This is very important because it actually determines the structure of the organic acids. And so its movement or its position will give the name for that particular actually acid. And some acids actually have isomers, meaning that this functional group, the carboxylic group, can move, and then it changes the name for and the structure for that organic acid. And so the general formula is as follows. We have carbon, and then N, hydrogen, 2N plus 1, and then carbon, oxygen, and the hydrogen. And we said this carbon, oxygen, hydrogen is known as the functional group, the carboxyl group. And so the structure formula, the way you write it is that you write the carbon and then 2 bonds to 1 oxygen. And then on the other side, you write the hydroxyl group, which is oxygen and the bond and hydrogen. And then the other side, it joins now the main compound. So this is actually the general formula. And so we start with naming the methanoic. As we said, the E at the end of methane has been replaced with the oic, and then you add the word acid. So here the E has been replaced with the oic, and then you add the word acid. And as we are aware, meth means there is only 1 carbon. So you're just going to have the functional group, which is the carboxyl group, and then hydrogen. Okay, and this is gotten by actually here. So we have 1 here, and then you have 2 times 1, which is 2, 2 plus 1, which is oil. Actually here, we start from 0. So here we're going to have 0, means 0 carbons, and then here we're going to have 2 times 0, which is 0, and then 1 carbon. Okay, so there will be 1 carbon because, so you start with 0. For naming actually the alcohols, you start with the actually 0, so that you have 1 hydrogen atom here. And that's why we have here 100. For methanoic, it means that you start with 1. So we're going to have 1 there, meaning that there will be 2 now with this one, 2 carbon atoms. Then H, 2 times 1, which is 2, plus 1, which is 3. So we're going to have 3 carbon atoms here and the carboxyl group. Similarly, for propanoic, it will be the same. Now we're going to have 2 here. We're going to have 2, and then 2 times 2, 4, plus 1, 5. And so this is what we are going to have. So Propanoic, because here we notice that these are 3, the 2 carbon atoms plus this one, which is 3. And similarly, butanoic acid, imagine all of them actually, remember that they are ending with the oic. So we have 3. So we are going to start with the now general formula 3 there. 3 times 2, which is 6, 6 plus 1, 7. And this is, we're going to have that one. And the but, as we said, there are 4 carbon atoms. So this 3 plus this one. And so on and so on. So this is basically how we can actually name and give the molecular formula for an organic acid. So now we go straight into looking at how we can actually write the structure formula for organic acids. We start with the functional group, as I indicated. We write the carbon, and then 2 bonds to oxygen, and then 1 bond to oxygen, and the hydrogen, which is the hydroxy group. And then we have remaining with 1 here, which is the hydrogen. So there are 4 bonds, 1, 2, 3, 4. So this is really the structure formula for methanoic acid. For ethanoic acid, we always start with the functional group. So write the functional group: carbon, double bonds, oxygen, bond to hydroxyl group, which is oxygen, bond, hydrogen. And then you connect now to 1 bond, with 1 carbon atom here, 1 carbon atom there, and around it there should be 4. 1, 2, 3, 4. Put hydrogen, hydrogen, and hydrogen. How many hydrogen atoms do we have? 1, 2, 3, 4. And here we have 3 plus 1, which is 4. So this is how we write the structure formula for ethanoic acid. And next, we write now the structure formula for propanoic acid. Start with the functional group, which is the carboxyl group. So write this one here. Oxygen to the hydroxyl group. Double bonds to oxygen. And here there are 2 carbon atoms. Write a bond, carbon, a bond, carbon. And around each carbon atom, you write 4 bonds. 1, 2, 3, 4. Even here, 1, 2, 3, 4. They write hydrogen there, hydrogen there, hydrogen there, hydrogen there, hydrogen, ensuring that there are 4 around. So even here there are 1, 2, 3, 4 bonds. So this is how we write the structure formula for actually propanoic acid. Even if this functional group would come this side, it will still be on carbon number 1. So this is on carbon number 1. The functional group here is on carbon number 1. Even if we brought this side, it will be on carbon number 1. Next, butane 1-oic acid. Butane 1-oic acid. Start with the functional group. Make sure this functional group is on carbon number 1. So we write this carbon, bond, carbon, bond, then the functional group, which is carbon, double bond, oxygen, bond to the hydroxyl group, which is oxygen, bond, hydrogen. And around we put now the hydrogen atoms. Write the hydrogen atoms, and there should be 4 around each carbon atoms. Even here there are 4. Note that here we have said 1 because it's this carboxyl group, the functional group is on carbon number 1. If we brought it here, it will still be on carbon number 1. But if we brought it in the middle here, it will be on carbon number 2. So it will change the structure, and yet the molecular formula will be the same. So it means that actually butane has 2 isomers, meaning they have different structure formulas, but the same molecular formula. Next, we go to butane 2-oic acid. So you write the carbon atoms, carbon, bond, carbon, bond, carbon. And we bring the functional group here, the carboxyl group, we bring it, the bond there to carbon, and a double bond to oxygen, then a bond to hydroxyl group, which is oxygen, a bond hydrogen there. And then there should be 4 around here. 1, 2, 3, 4. Then around this carbon, there will be 1, 2, 3, 4. Around this one, there will be 1, 2, 3, 4. Around this one, there will be 1, 2, 3, 4. And then you put the hydrogen atoms. And so I thought this is very important because we need to know what isomers are. That is the species which have actually different structural formulas, and yet they have similar molecular formulas. And it's very important that we understand how to write these structural formulas because they are required actually when we'll be writing now on how these actual compounds react with the other compounds. So remember to subscribe to my YouTube so that you actually gain more knowledge. Thank you.